So we have x plus 1 root 27 equal to x root 9, and we have to find the value of x. So I noticed that x is in our index, which is kind of atypical because, I don't know about you, I'm used to having x inside the radicals, not on the outside, but don't worry, we'll figure it out. Now, the first thing that we're going to try to do is, to make this a little easier, we are going to actually convert our radicals to exponents. Now, if you don't know, you can actually convert a radical to an exponent. So if you're given b root x to the a, well, that's the equivalent of saying x to the a all over b. So what we're going to do is convert both of our radicals to exponents using this rule. So x plus 1 root 27, well, that's the same thing as saying x plus 1 root 27 all raised to the 1. So when we convert it to an exponent, that would be equal to 27 to the 1 all over x plus 1. Now we're going to do the same thing for x root 9. Now once again, x root 9 is the same thing as saying x root 9 to the 1. Okay, so when we convert this to an exponent, that will be equal to 9 to the 1 all over x. So now we've converted our radical equation to an exponential equation, which is going to be a little easier to solve. Now, when we solve for exponential equations, remember one of the ways that we can solve for them is to try to get our exponents to have like bases. So as you see, on the left side our base is 27, and on the right side our base is 9. But let's see if we can find a way to get these bases to be alike. So I know that 27 is the same thing as saying 3 cubed, right? And I know that 9 is the same thing as saying 3 squared. So what we're going to do is rewrite 27 to become 3 cubed and 9 to become 3 squared. And when we do that, that'll leave us with 3 cubed to the 1 all over x plus 1 equal to 3 squared to the 1 all over x. We're going to clean this up a little. If you look at our exponents, we're going to actually use power rule, because when we have a power raised to a power, what we can do is just multiply those powers together. So as you see, we have 3 to the 1 all over x plus 1. What we're going to do is just multiply that 3 to the 1 all over x plus 1, and that will give us 3 all over x plus 1. We're going to do the same thing for the right side. We have 2 raised to the 1 all over x. We're just going to multiply that 2 to the 1 over x, and that will give us 2 all over x. And when we clean it up, we'll be left with 3 to the 3 all over x plus 1 equal to 3 to the 2 all over x. Okay? Now, as you see, our exponents have like bases, which means we can now set their powers equal to each other. Now, the reason we do this, if you don't know, is because in order for these exponents to be equal, well, their powers have to be equal to each other as well. So since we have the bases equal to each other, well, we can now just isolate it to their powers to figure out what x is. So we're going to set 3 all over x plus 1 equal to 2 all over x, and then we're going to solve for x. So to solve for x, what we can do is cross multiply. So we're going to do 3 times x, which will give us 3x, and then x plus 1 times 2, which will give us 2 times x plus 1, and then we can distribute that 2 to the x plus 1, and 2 times x is 2x, and then 2 times 1 is 2, and that'll leave us with 3x equal to 2x plus 2. From here, we can subtract 2x on both sides, and then we'll get x equal to, and the value that's equal to is just going to be 2. And lo and behold, we get the value of x. Now, of course, when it comes to solving for x, we want to verify that this is correct by plugging it back to the original equation. So when we plug it back in, we'll get 2 plus 1 root 27 equal to 2 root 9. Now 2 plus 1 is 3, so that's basically the cube root of 27. And then 2 root 9 is basically the square root of 9. We just typically don't write the 2. But I know that the cube root of 27 is 3, and the square root of 9 is 3. Therefore, this confirms that x is 2 because 3 is equal to 3. So the answer is going to be 2. And there you have it.